The engine is seized. We can't move it.
The road is impassable anyway. Look at the map.
Look at this mess! We cannot bypass this section. We need engineers immediately.
I am noting the damage, Captain, but the timeline is impossible.
Keep moving! Push through the gap!
Watch the right side! Go! Right here, penetration on the glasses. Must have been a hell of a shot.
September 1944. Northern France. A Sherman tank sits crippled at the edge of a narrow road, its track torn open by shell fire. Smoke still clings to the hedgerows. The engine is silent, but the war has not moved on. It has paused, waiting. Beside the tank, men in grease-stained uniforms work under dim hooded lamps. Wrenches strike metal. Steel cables tighten. A mobile crane groans as it lifts armor plates weighing more than a small car. There is no factory here, no rear depot, only a roadside workshop carved out of urgency and time. German artillery rumbles somewhere beyond the fields. Yet the mechanics do not look up. They have done this before. In daylight, under fire, sometimes within range of enemy rifles. Across the lines, German engineers have reported destroyed vehicles with certainty. A tank disabled at dusk is counted as lost. But by dawn, that same tank often returns, moving, firing, advancing again. To German officers studying maps and loss reports, it makes no sense. Machines do not resurrect overnight. Not without factories. Not without weeks. But the Americans have brought something new to the battlefield. And it is not a weapon. It is a system, moving forward with the war itself, reshaping how battles are sustained, and quietly setting the stage for what comes next. By the time American forces set foot in Normandy in June 1944, the war had already taught every major power a brutal lesson. Battles were no longer decided by courage alone. They were decided by endurance. And endurance depended on logistics. Germany entered the war with a reputation for engineering excellence. Its armored vehicles were formidable, often superior in armor thickness and firepower. But German military doctrine had grown around a central assumption. Damaged vehicles would be recovered, transported to rear area depots, and repaired by specialized crews far from the front. This system worked in short campaigns. It worked in Poland. It worked, briefly, in France in 1940, but depended on time, and on territory that remained secure. As the war expanded, those assumptions collapsed. On the Eastern Front, vast distances strained German recovery units. Rail lines were sabotaged. Repair depots were overrun or destroyed. Tanks that might have been saved were abandoned simply because they could not be moved quickly enough. German engineers were skilled, but they were bound to static infrastructure. The United States studied these failures closely. Even before entering the war, American planners understood something shaped by their own industrial culture. American factories thrived on standardization, interchangeable parts, assembly line logic. A broken machine was not a unique puzzle. It was a system with replaceable components. This philosophy was carried into military planning. The U.S. Army Ordnance Department, responsible for maintenance and repair, rejected the idea that vehicles should retreat from the battlefield to be healed. Instead, they imagined repair moving forward, following the troops, adapting to the terrain, improvising when necessary. Early tests of this concept came in North Africa. In 1942 and 1943, American armored units learned painful lessons against experienced German formations. Tanks were lost not only to enemy fire, but to breakdowns in heat, sand, and constant movement. Yet something unexpected emerged. Vehicles repaired close to the front returned faster, and crews fought with greater confidence, knowing damage did not always mean final loss. By Sicily and Italy, mobile maintenance units had become more refined. Ordnance companies were attached directly to combat divisions. Recovery vehicles dragged disabled tanks out of danger. Mechanics learned to work with minimal cover. Repairs once thought impossible outside factories were now performed under canvas in orchards beside roads. German observers noticed. Reports from Italy describe American vehicles returning with abnormal speed. Intelligence officers struggled to explain it. There were no large depots visible, no rail movements to account for the numbers. What they were witnessing was not improvisation, it was doctrine taking shape. And by the time Allied forces prepared for the invasion of Western Europe, that doctrine was ready to be tested on an unprecedented scale. In the months leading up to D-Day, American planners understood that the invasion of Western Europe would place impossible demands on any traditional repair system. Beaches would be crowded, roads would be destroyed, ports would be unusable or heavily damaged. If armored and motorized units were forced to retreat hundreds of kilometers for maintenance, momentum would vanish within days. The solution was built quietly, long before the first landing craft touched sand. The U.S. Army expanded its Ordnance Corps into a layered, mobile structure. First echelon maintenance remained with unit crews, basic fixes under fire. Second echelon units, the heart of the system, moved just behind the front lines. These were the mobile repair companies, equipped with machine tools, welding equipment, spare engines, transmissions, and standardized components. They could rebuild vehicles in the field. Third echelon depots existed farther back, but only for the most severe damage. Standardization made this possible. American tanks, trucks, and artillery pieces were designed with modular parts. An engine block removed from one Sherman could be installed into another without modification. Tracks, road wheels, and gearboxes followed the same logic. Mechanics trained in one theater could work effectively in another. Training emphasized speed over perfection. A repair did not need to be elegant. It needed to return the vehicle to combat readiness. Crews were drilled to work at night, to camouflage repair sites, to recover vehicles under artillery threat. Recovery vehicles like the M31 and M32 tank recovery vehicles became as essential as tanks themselves. By June 1944, hundreds of these units crossed into Normandy with the assault waves. They landed without fanfare. No cameras followed them. Their work began almost immediately, pulling drowned vehicles from surf, stripping salt-corroded engines, rebuilding transmissions under tarps as German shells fell nearby. As Allied forces broke out of Normandy and began the rapid advance across France, the system revealed its true strength. Distances stretched, supply lines lengthened. German units attempted to slow the advance by destroying bridges and ambushing columns. Vehicles were damaged daily, not catastrophically, but enough to halt movement. American mobile repair crews answered by moving forward again. Workshops were located every few days. Spare parts followed the same roads as ammunition and fuel. The Red Ball Express carried not just supplies, but replacement engines and gearboxes delivered directly to roadside repair sites. German engineers, trained to value precision and factory conditions, struggled to comprehend what they encountered. Captured vehicles showed signs of crude welding, mismatched components, and improvised fixes, yet they functioned. Tanks deemed destroyed reappeared. Loss calculations became unreliable. By late summer 1944, German staff officers were forced to accept an uncomfortable reality. The Americans were not simply replacing losses faster. They were preventing losses from becoming permanent. And this realization would soon intersect with the human, tactical, and moral dimensions of the war itself. Behind every recovered vehicle stood men whose war was measured not in territory gained, but in hours stolen back from failure. Most American mechanics were not engineers by trade before the war. They were factory workers, farmers, auto repairmen. The Army trained them quickly and sent them forward faster than doctrine had ever allowed. Their hands learned steel, through repetition. Their confidence grew not from heroics, but from results. They worked without the expectation of recognition. Combat reports rarely mention them, yet they operated within range of small arms, often under shell fire. Night repairs were common, chosen not for convenience, but survival. Mechanics slept beside vehicles they were restoring, waking to continue work at first light. When a tank crew returned to find their machine running again, the exchange was brief. A nod, a handshake, then the tank moved back toward the front. For American commanders, mobility was everything. A disabled vehicle was not merely lost firepower. It was a gap in momentum. Mobile repair crews became an extension of maneuver warfare. By reducing repair time from weeks to hours, they allowed armored columns to maintain pressure. German defenses, already strained, faced units that seemed immune to attrition. This disrupted German planning. Ambushes designed to immobilize advancing forces no longer achieved their intended effect. A knocked-out track delayed an advance briefly, not decisively. The front did not pause long enough for German units to regroup. American vehicles were not flawless. Shermans broke down frequently. Trucks wore out under constant movement, but they were designed to be fixed. Bolts aligned, parts fit, tools matched. German vehicles, though powerful, were complex. Field repairs often required specialized equipment unavailable near the front. This difference was not accidental. It reflected two philosophies of war, one seeking technical superiority, the other seeking operational continuity. And as these philosophies collided, the human cost, leadership decisions, and enemy reactions would reveal just how decisive this unseen struggle had become. At the highest levels, American commanders understood that battles could not be won faster than machines could move. General Dwight D. Eisenhower emphasized sustainment as a command responsibility, not a technical afterthought. General Brehon Somervell, overseeing Army service forces, pushed relentlessly for efficiency, standardization, and forward deployment of support units. Their influence ensured that maintenance companies received transport priority, fuel allocations, and authority to operate close to combat formations. This leadership stance mattered. It legitimized the presence of mechanics at the front and protected them from being pulled rearward when risks increased. Repair units were not treated as expendable specialists. They were treated as combat multipliers. German engineers observing captured American vehicles noticed patterns that defied expectation. Armor plates welded crudely back into place. Components bearing serial numbers from different factories. Temporary fixes that would never pass peacetime inspection. Yet these machines functioned. Reports from German maintenance officers described frustration at the Americans' indifference to refinement and their willingness to accept visible imperfection in exchange for immediate utility. Prisoner interrogations echoed the same theme. German soldiers expressed disbelief at how quickly American units recovered. What had been counted as destruction revealed itself as delay. This system altered the psychological landscape of the battlefield. American crews fought with the knowledge that damage did not always equal death. Survival extended beyond the moment of impact. German crews, facing mechanical loss as final loss, experienced a different pressure. Machines abandoned became symbols of defeat. In this quiet moral divide, the stage was set for a turning point where logistics, endurance, and belief would converge under the most severe test of the war. Late July 1944. Normandy, France. The sky above the bocage trembles long before the first bombs fall. Waves of Allied aircraft roll overhead, their engines merging into a single mechanical roar. When the bombardment begins, the ground convulses. German defensive lines fracture under steel and fire. Operation Cobra has begun, not as a slow push, but as a rupture. For American armored units waiting at the edge of the shattered front, the signal is unmistakable. Move. Move without pause. Move before the enemy can recover. Sherman tanks surge forward through gaps torn open by air power. Columns of trucks follow, dust clouds stretching for miles. The advance accelerates faster than planners once believed possible. Roads never meant for continuous traffic now carry the weight of modern mechanized war. Within days, the problem is no longer enemy resistance alone. It is exhaustion of machines. Tracks grind against rubble. Engines overheat in the summer heat. Suspensions crack under constant vibration. Vehicles are damaged not just by German fire, but by relentless momentum. In previous wars, such strain would have forced a halt. Units would consolidate. Repair depots would catch up. This time, the depots move forward instead. Behind the spearheads, American mobile repair crews begin a second, quieter offensive. Ordnance maintenance companies advance almost as quickly as the tanks themselves. They do not wait for permanent facilities. A roadside becomes a workshop. A hedgerow becomes cover. A bombed-out barn becomes a repair bay. Recovery vehicles, M31S and M32S, pull disabled tanks from the fields while shells still fall nearby. Winches groan under weight measured in tons. Mechanics work in teams, stripped of excess gear, focused on speed. There is no ceremony to the work, only sequence. Disconnect, lift, replace, test, move. Time is measured not in days, but in hours. German engineers retreating through Normandy expect the usual signs of attrition. Wrecked vehicles, abandoned armor, columns stalled by mechanical failure. Instead, they encounter an absence. Roads are cleared. Disabled American vehicles vanish overnight. Loss estimates fail to match what appears at the front. This confounds German planning. Reports from frontline units indicate repeated engagements with American armor previously marked as destroyed. Intelligence officers question the data. Engineers question their assumptions. The assumptions, it turns out, are outdated. American tanks are not preserved in perfect condition. They bear scars, weld marks, improvised fixes, components replaced with mismatched parts. But they run. They fire. They move. Perfection has been sacrificed for continuity. As the breakout widens, repair crews begin leapfrogging positions. One workshop closes as another opens farther east. Supplies follow them. Engines delivered directly to the roadside. Transmissions swapped in open fields. Spare parts flow along the same arteries as fuel and ammunition. The Red Ball Express becomes the bloodstream of this system. Its drivers haul not only food and shells, but entire drivetrains. Mechanics learn to expect deliveries at odd hours. Repairs are scheduled around convoy arrivals, not daylight. German countermeasures focus increasingly on immobilization. Ambushes aim for tracks. Mines target suspensions. Artillery fires at road junctions. The goal is delay. If the Americans can be slowed, perhaps they can be worn down. But delay no longer equals destruction. A tank with a shattered track is hauled clear within hours. A burned-out engine is replaced rather than rebuilt. Crews trained for speed complete tasks, once reserved for factories. The front absorbs damage and continues forward. By early August, the tempo of the advance begins to break German operational cohesion. Commanders plan counterattacks against units they believe depleted, only to encounter formations operating near full strength. The Americans appear immune to cumulative damage. The psychological effect is unmistakable. German engineers, long accustomed to valuing precision and controlled environments, now face an opponent willing to accept roughness in exchange for immediacy. The battlefield itself has become a factory floor, one that moves. As American forces race toward the Seine, the gap between German expectations and reality widens into strategic blindness. Vehicles abandoned for lack of parts become common. crews destroy their own machines rather than let them fall intact. Fuel shortages compound the problem. Repairs become meaningless when movement is impossible. At Falaise, this imbalance reaches its most visible expression. German columns choke the roads, immobilized by destruction, lack of fuel, and mechanical failure. Recovery is impossible. Time has run out. Across the lines, American repair crews continue their routine. Tanks damaged in the pursuit are fixed and sent forward again. There is no pause to reflect on the contrast. By late August, German staff officers begin to articulate the truth in after-action reports. They're not simply being outfought. They're being outsustained. The Americans have found a way to turn damage into delay, and delay into nothing at all. This realization does not end the war, but it marks the moment when German hopes of slowing the Allied advance through attrition quietly collapse. And as the front stretches toward the German border, the system that made this possible prepares to face a far colder, more unforgiving test. December 1944. The Ardennes forest. Snow falls in thick, soundless sheets, settling over trees, roads, and wreckage alike. The temperature drops well below freezing. Engines refuse to turn. Metal contracts. Oil thickens. For soldiers at the front, the cold is an enemy as real as any man in uniform. This is where the German High Command places its final gamble. Operation Wacht am Rhein, the Ardennes offensive, strikes with speed and surprise. American units are hit in sectors considered quiet, their lines thin, their defenses incomplete. German armor pushes forward through fog and forest, aiming to fracture the Allied front and reach the Meuse. In the opening days, American formations reel. Roads clog with refugees, retreating units, and abandoned equipment. Vehicles freeze in place overnight. Fuel runs low. Visibility collapses. For a brief moment, German commanders believe they have found the weakness they sought. But beneath the chaos, the repair system begins to move again. Mobile maintenance units that had followed the advance across France now pivot into survival mode. Workshops relocate into forests, villages, and frozen clearings. Canvas stiffens with ice. Tools numb bare hands. Mechanics work in gloves when possible, bare fingers when necessary. The nature of repair changes. In Normandy, speed had been the priority. In the Ardennes, it is survival. Engines are warmed with fires lit beneath oil pans. Fuel lines are cleared manually. Batteries are swapped constantly. Tracks snap in the cold and must be replaced under conditions that punish every mistake. German planners assume these conditions will grind American mobility to a halt. Their own experience tells them so. Cold has always favored defense. Machines fail. Men slow. Yet American vehicles keep returning. A truck frozen solid at dawn moves again by afternoon. Tanks immobilized by cold are dragged to cover, repaired, and reintroduced into defensive lines within days. Recovery crews operate under artillery fire, hauling vehicles through snow-choked roads. German engineers encounter the same unsettling pattern seen in France, now intensified by winter. Vehicles damaged during the initial breakthrough are not permanently lost. They reappear, reinforcing positions that should have collapsed. As the battle deepens, this resilience shapes outcomes. At Bastogne, surrounded American units rely on every functional vehicle. Repairs are conducted under siege conditions. Spare parts are rationed. Improvisation becomes doctrine. German units, advancing on narrow supply lines, face their own mechanical attrition. Fuel shortages strand vehicles. Breakdown equals abandonment. Recovery is impossible under constant air threat once the skies clear. By January 1945, the offensive has stalled. German forces lack the mobility to exploit early gains. American units, reinforced and repaired, push back. Vehicles that should have been counted out weeks earlier now participate in the counterattack. German after-action assessments identify the imbalance plainly. American mechanical recovery and repair capacity has negated environmental advantage. Attrition has failed again. The Ardennes marks the final proof. Not just that American mobile repair works, but that it works under the worst conditions modern war can impose. From the frozen forests of Belgium, the lesson travels quickly through German command channels. This is not a temporary advantage. It is systemic, and it cannot be overcome by courage, engineering skill, or tactical surprise alone. As the snow begins to melt and the front moves eastward once more, the war's outcome is no longer in doubt. What remains is the reckoning with what this quiet system has already decided. By the time the fighting in the Ardennes subsided in January 1945, the physical evidence of the war told a stark and uneven story. Roads across Belgium and Luxembourg were littered with wreckage, but most of it was German. Burned-out Panthers and Tigers sat frozen where fuel or mechanical failure had ended their journey. American vehicles, by contrast, were fewer in number and often absent entirely, not because they had escaped damage, but because damage had not meant permanence. This difference reshaped the final months of the war in Western Europe. American armored divisions entered 1945 with a level of operational readiness that defied traditional expectations. Vehicles lost in action were replaced or restored with astonishing speed. Ordnance reports from late 1944 and early 1945 reveal that a significant percentage of tanks and trucks classified as combat damaged were returned to service within days, not weeks, many within hours. The front line rarely felt the full weight of attrition. This was not accidental. It was the result of a repair system that had matured under pressure and proven itself under fire. By early 1945, mobile repair units were no longer an innovation. They were a permanent feature of American warfare. Ordnance maintenance companies operated in tightly coordinated networks, each assigned to specific divisions, corps, and army-level formations. Recovery teams knew their sectors intimately. Spare parts were pre-positioned based on expected failure rates. Damage was anticipated, not merely responded to. German commanders, studying the situation, faced a harsh arithmetic. Every tank lost was nearly irreplaceable. Germany's industrial base, under constant bombing, struggled to deliver new vehicles. Spare parts were scarce. Skilled labor was stretched thin. Repairs that might have been possible on paper were impossible in practice. The result was an accelerating asymmetry. In February 1945, as Allied forces pushed toward the Rhine, German units often entered engagements already under strength. Tanks were rationed. Vehicles were cannibalized to keep a few running. Maintenance crews worked with skill and desperation, but without time, fuel, or parts, their efforts could not match the American system. Captured German maintenance officers spoke candidly in post-battle interrogations. They described frustration at seeing American vehicles return again and again. One intelligence summary noted German disbelief at the practical immortality of Allied motor transport. The phrase was not admiration. It was resignation. Numbers confirmed the impression. While American forces suffered enormous mechanical wear during the final advance, the proportion of vehicles permanently lost remained comparatively low. Trucks that would have been abandoned in earlier wars were repaired roadside. Tanks disabled by mines or artillery were often recovered, rebuilt, and returned to units before replacements could even be issued. This had consequences beyond material counts. American commanders gained freedom of action. They could plan offensives without lengthy pauses for refit. The pace of operations increased. German defenses, already weakened, were denied the recovery time they desperately needed. Every retreat became more chaotic. Every delay more costly. For German troops, the psychological impact was severe. Vehicles were not just tools, they were lifelines. Losing one meant loss of mobility, firepower, and often survival. Watching enemy machines return after being damaged eroded confidence. The battlefield no longer offered the reassurance that inflicting damage would yield lasting results. The Rhine crossings in March 1945 illustrated this imbalance clearly. American units massed vehicles rapidly at crossing points. Damaged equipment was repaired in staging areas within range of enemy fire. Engineers built bridges while mechanics kept traffic moving. German attempts to disrupt the crossings through artillery and demolition inflicted damage, but not decisive delay. Once across the Rhine, the final advance into Germany unfolded with relentless momentum. Town after town fell. German units withdrew or surrendered. Vehicles abandoned due to breakdowns lined the roads. American columns advanced with a mechanical resilience that left little room for German recovery. Behind the scenes, the repair crews continued their work. Engines swapped, tracks replaced, axles straightened. The system functioned almost invisibly, even as it determined outcomes. By April 1945, German resistance in the West was collapsing. Industrial capacity lay in ruins. Logistics had failed. Repair had become impossible. What remained of German engineering excellence could not overcome the absence of fuel, time, and secure territory. The American system, by contrast, had absorbed everything the war could throw at it. Summer heat, mud, snow, constant movement, enemy fire. It emerged not untouched, but intact enough to sustain victory. As the guns fell silent in May, the material imbalance left behind spoke as loudly as any surrender document. The war had not been won by machines alone, but it had been decided by how quickly machines could return to the fight. And in the reckoning that followed, both sides would be forced to confront what this meant for the future of warfare itself. By the spring of 1945, the implications of the American mobile repair system had become clear, not just to historians, but to the surviving German engineers and military planners who had witnessed it firsthand. The war in Western Europe had been decisively shaped by a factor often invisible to the frontline soldier: the relentless ability to recover, repair, and redeploy vehicles under any conditions. While German forces had relied on static depots and carefully maintained supply lines, the U.S. Army had turned the battlefield itself into a dynamic, moving workshop. This systemic advantage would influence post-war military doctrine and the very nature of mechanized warfare. German post-war analyses stressed this point repeatedly. In captured reports and memoirs, senior officers acknowledged that the rapid restoration of American vehicles directly contributed to the collapse of German resistance in France, Belgium, and the Rhineland. One report from a Wehrmacht engineer noted, "Our calculations of American armored losses were meaningless. Tanks we had counted as destroyed reappeared almost immediately, fully operational. We were never able to match such recovery under fire." Another analysis emphasized that German reliance on rear area repair and factory maintenance was fundamentally incompatible with the pace and fluidity of modern mechanized combat, a lesson reinforced under the punishing conditions of the Ardennes winter. The numbers underline this disparity. By late 1944, U.S. Ordnance Corps reports indicate that more than 60% of damaged Sherman tanks were returned to operational status within 72 hours of being disabled, and many within 24 hours. Trucks, vital for the Red Ball Express and armored support, experienced similarly high repair rates. German forces, by contrast, often abandoned vehicles at the first sign of breakdown, sometimes destroying them to prevent capture. Entire formations became stranded due to mechanical failure compounded by fuel shortages, a situation exacerbated by the Allied bombing campaign, which further disrupted German logistics. This contrast did not just impact material calculations. It altered the tempo and psychology of the war. U.S. commanders could operate under the assumption that losses were temporary and reparable. Strategic planning incorporated forward maintenance as an active tool, allowing units to exploit breakthroughs without pausing for attrition to take its toll. German commanders, witnessing the resilience of American formations, were forced to assume the worst in every engagement. Ambushes and counterattacks lost their effectiveness when disabled American vehicles were repaired before the next day. The battlefield no longer rewarded static tactics or calculated attrition. It rewarded flexibility, mobility, and preparation. The cumulative effect of this system is particularly evident in the final advance into Germany. American mechanized units pressed eastward relentlessly, sustaining momentum in ways previously unimaginable. Where German units were delayed or immobilized, Americans were repairing in place, often at night, under artillery fire and in freezing temperatures. Mechanic teams became a strategic force multiplier, allowing divisions to maintain operational readiness that far exceeded nominal vehicle counts. Recovery and repair were not support functions, they were decisive. Post-war studies of U.S. ordnance operations in Europe highlight how this experience influenced future military logistics doctrine. The idea of forward-deployed repair units became a central tenet of mechanized warfare planning. Modular equipment design, standardization of components, and mobile recovery vehicles were incorporated into post-war armor doctrine in both the U.S. and NATO forces. The effectiveness of American repair crews under fire demonstrated that mechanical sustainability was not merely administrative. It was a direct contributor to operational success. Even culturally, the reputation of these repair units influenced post-war memory. They were rarely celebrated in popular media, overshadowed by tank aces and infantry heroism, yet their impact was deeply felt. Generals, intelligence officers, and soldiers alike recognized the quiet power of mobility and maintenance in sustaining victory. The contrast between American operational endurance and German mechanical attrition became a textbook example of how logistics can shape the outcome of modern warfare. By the end of the war, the lesson was clear. Speed, adaptability, and recovery could determine the outcome even as frontline engagements continued. German forces, no matter how well-trained or equipped, could not compete with a system designed to absorb damage, correct it rapidly, and redeploy assets in real time. The battlefield had become a laboratory for logistical innovation, and the Americans had proven that maintenance, repair, and recovery were as decisive as tanks or artillery in determining who would prevail. The final months of fighting in Europe, from the Ardennes to the Rhine, solidified this reality. Victory was not only a matter of attrition or firepower, it was a measure of resilience. Mechanized units, sustained by forward repair crews and mobile ordnance teams, maintained pressure continuously. German defenses crumbled under this unrelenting operational tempo. The Allies' ability to repair and return vehicles to the fight erased advantages that might have otherwise slowed or halted their advance, turning mechanical restoration into a weapon in its own right. The systemic nature of American repair capabilities left a lasting imprint on military thought. Modern armies now integrate maintenance and recovery into planning at the tactical and operational levels. The lessons of 1944 to 1945 illustrate that wars are won not only by the weapons used, but by the systems that sustain them. The quiet, tireless work of American mobile repair crews transformed damaged vehicles into combat-ready machines and, in doing so, accelerated the collapse of German resistance. One repaired engine, one replaced track, one restored tank at a time. The battlefield of Western Europe thus ended not solely with the roar of tanks and artillery, but with the steady, persistent rhythm of wrenches on steel, engines fired up beside hedgerows and frozen forests, and crews working under impossible conditions. The Americans had demonstrated that mechanical resilience was as lethal as any weapon, and that victory could be engineered not only through combat, but through the orchestration of repair, recovery, and relentless forward momentum. The story of American mobile repair crews in World War II is not one of glory in the traditional sense. There were no headlines, no cinematic charges, no single act of heroism that could capture their contribution. Yet their impact was profound, shaping the outcome of battles, the pace of campaigns, and the very logic of mechanized warfare. They revealed that war is not only fought with weapons, but with systems, organized, resilient, and unyielding. Their work blurred the line between combat and support. Each repaired engine, each replaced track, each vehicle returned to the fight became a quiet act of strategy. Momentum, the essential lifeblood of modern warfare, depended on them. While bullets and shells determined who would fall in the moment, it was the ability to rise again that determined who would survive the campaign. In Normandy, in France, in the Ardennes, Americans demonstrated that operational continuity could outweigh temporary tactical success. The Germans' astonishment was not merely professional, it was existential. They faced an opponent who refused the finality of damage, a system in which loss was only temporary, repair inevitable, and progress relentless. Their carefully honed doctrines, emphasizing precision and rear area recovery, were rendered ineffective by speed, adaptability, and foresight. This disparity became a decisive factor in the collapse of German resistance in Western Europe. Beyond the battlefield, this approach left a lasting legacy. It reshaped military logistics, inspiring post-war doctrines that emphasized modularity, standardization, and mobility. It taught future commanders that victory depends as much on sustaining forces as on striking them. And it illuminated a human truth, that endurance, discipline, and quiet competence can be as powerful as courage and firepower. In the end, the lesson of the mobile repair crews is a reminder that war is never only about destruction. It is about restoration, adaptation, and the ability to keep moving forward when the world insists on stopping you. On those roads of Normandy and in the frozen forests of Belgium, history was made not just by the tanks that fired their guns, but by the hands that made them roll again.